Hi, let's see chapter 6 triangles today. We have tried to make it very simple and very interesting for you. So stay till the end and see how easy this chapter is once you understand it well. Let's begin with a few basic concepts first. Congruent. Two figures having the same shape and the same size. Similar are two figures that have the same shape but not necessarily the same size. All congruent figures are similar, but similar figures need not be congruent. Two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. The same ratio of the corresponding sides is referred to as the scale factor or the representative fraction for the polygons. Let's do exercise 6.1. Fill in the blanks with the appropriate words. All circles are, well, similar, right? Same shape, not necessarily the same size. Now, all squares are, the answer would be similar. Same shape, not necessarily the same size. Now, all dashed triangles are similar. So, what do you think? All equilateral triangles are similar because sides are in the same ratio. Next is two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. Give an example of a pair of similar figures. So these two rectangles have the same shape but not the same size, so they are similar. Non-similar figures, any two figures that doesn't have the same shape. Now state whether the quadrilaterals shown here are similar or not. Well, since the corresponding angles in both the polygons are not equal, these two are not similar. If corresponding angles of two triangles are equal, then they are known as equiangular triangles. Let's see the basic proportionality theorem now. It says if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the two sides are divided in the same ratio. Let's see the proof now. This is triangle ABC in which a line parallel to the side BC intersects other two sides AB and AC at D and E respectively. We need to prove that AD upon DB is equal to AE upon EC. Let us join BE and CD and then draw EM perpendicular to AB and DN perpendicular to AC. Now area of triangle ADE would be equal to area of triangle ADE because we are talking about the same triangle, right? So area of triangle ADE can be half into AD into EM when AD is taken as the base, and it can also be equal to half into AE into DN when AE is taken as base. Now, area of triangle EBC would also be equal to area of triangle DBC because triangles on the same base and between the same set of parallel lines have equal areas. So, half into DB into EM would be equal to half into EC into DN. Now, let's divide equation 1 by equation 2. We get this. And ultimately, we get AD upon DB would be equal to AE upon EC. Interesting, right? Let's move on to theorem 2. This is the converse of the previous theorem. It states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Now we are given that this line divides two sides in the same ratio, and we have to prove that this line is parallel to the third side. Let's draw a line DF which is parallel to BC, assuming that DE is not parallel to BC. Now, since DF is parallel to BC, according to BPT theorem, AD upon DB would be equal to AF upon FC. But we are given that AD upon DB is equal to AE upon EC. So that means AF upon FC would be equal to AE upon EC. Now, when is this possible? Only when E and F coincide. Therefore, DE is parallel to BC. Now, let's see an example where we apply the basic proportionality theorem. If a line intersects sides AB and AC of a triangle ABC at D and E respectively and is parallel to BC, prove that AD upon AB is equal to AE upon AC. So we are given that DE is parallel to BC and we need to prove that AD upon AB is equal to AE upon AC. Now AD upon DB is equal to AE upon EC because DE is parallel to BC and according to BPT theorem, the sides are proportional. The line divides the sides in the same ratio. Now, the reverse of it would also be true. That means DB upon AD would be equal to EC upon AE. Now, let's add 1 to both the sides. We get AB upon AD is equal to AC upon AE. Reversing again, we get AD upon AB is equal to AE upon AC, and this is what we wanted to prove. Moving on to the next one, example 2. It says ABCD is a trapezium with AB parallel to DC. E and F are points on non-parallel sides AD and BC respectively such that EF is parallel to AB. We have to show that AE upon ED is equal to BF upon FC. Let's do a construction first. Join AC to intersect EF at G. Now AB is parallel to DC and EF is parallel to AB. We are given that. So EF would be parallel to DC because lines parallel to the same line are parallel to each other as well. Or we can also say EG, which is a part of EF, is parallel to DC. Now in triangle ADC, AE upon ED would be equal to AG upon GC according to BPT theorem. Now GF would also be parallel to AB, which would imply that in triangle CAB, CF upon FV is equal to CG upon GA. So this implies that BF upon FC is equal to AG upon GC. From equation 1 and 2, we get AE upon ED is equal to BF upon FC, and this is what we wanted to prove. Moving on to the next one. In the given figure, PS upon SQ is equal to PT upon TR and angle PST is equal to angle PRQ. We need to prove that PQR is an isosceles triangle. Now we are given that PS upon SQ is equal to PT upon TR. So this implies that ST is parallel to QR, converse of BPT theorem. Therefore, angle PST is equal to angle PQR, corresponding angles. Also, we are given that angle PST is equal to angle PRQ. This implies that angle PQR is equal to angle PRQ. Therefore, PQ is equal to PR because sides opposite to the equal angles are equal. Therefore, triangle PQR is an isosceles triangle. Hope you are liking the video. Please press the like button and encourage us. Let's see exercise 6.2 now. Let's see exercise 6.2. First part of question 1. If DE is parallel to BC, find EC. So we are given that DE is parallel to BC. Now by BPT theorem, AD upon DB would be equal to AE upon EC. That means 1.5 upon 3 would be equal to 1 upon EC. So we can say that EC is equal to 2 centimeter. Similarly, in the next part, we are given that DE is parallel to BC and we need to find AD. Now again, AD upon DB would be equal to AE upon EC by BPT theorem. So that would mean that AD upon 7.2 would be equal to 1.8 upon 5.4. That means AD is equal to 2.4 centimeter. Let's see question 2 now. E and F are points on the sides PQ and PR respectively of triangle PQR. For each of the following cases, state whether EF is parallel to QR or not. Let's see the first part now. This is what is given, which would mean that PE upon EQ would be 3.9 upon 3, which gives us 1.3. Now, PF upon FR would be 3.6 upon 2.4, which would give us 1.5. So we can see that PE upon EQ is not equal to PF upon FR, and hence EF is not parallel to QR. Second part says, this is what is given. Finding the ratio, we get PE upon EQ equal to 4 upon 4.5, which is 8 upon 9. And similarly, PF upon FR would be 8 by 9. So we can clearly see that PE upon EQ is equal to PF upon FR. So we can say that EF is parallel to QR by converse of BPT theorem. Next part is, this is what is given and we'll find the ratio. But first, we need to find EQ because EQ is not given in this case, PQ is given. So EQ would be PQ minus PE. So it will be 1.28 minus 0.18, which is 1.1 centimeter. Similarly, before that, PE upon EQ would be 0.18 upon 1.1. And similarly, FR would be equal to PR minus PF. So it will be 2.56 minus 0.36. We get 2.2 centimeter. So PF upon FR would be 0.36 upon 2.2, which gives us 18 upon 11. Same as PE upon EQ. So we can clearly say that PE upon EQ is equal to PF upon FR, which means by converse of BPT theorem, EF is parallel to QR. Let's see question 3 now. If LM is parallel to CB and LN is parallel to CD, prove that AM upon AB is equal to AN upon AD. In triangle ABC, AM upon MB is equal to AL upon LC since LM is parallel to CB by BPT theorem. Similarly, in triangle ADC, AN upon ND would be equal to AL upon LC by BPT theorem again. From these two equations, AM upon MB is equal to AL upon LC and is also equal to AN upon ND. Thus, AM upon MB is equal to AN upon ND. Reversing it, we get MB upon AM is equal to ND upon AN. Now let's add 1 to both the sides. We get MB upon AM plus 1 is equal to ND upon AN plus 1. Thus we get MB plus AM upon AM is equal to ND plus AN upon AN. So AB upon AM is equal to AD upon AN. Reversing it again, AM upon AB is equal to AN upon AD. This is what we had to prove. Question 4. DE is parallel to AC and DF is parallel to AE. Prove that BF upon FE is equal to BE upon EC. In triangle ABC, since DE is parallel to AC, by using basic proportionality theorem we get BD upon DA is equal to DE is equal to BE upon EC. In triangle BAE, DF is parallel to AE, thus by using BPT theorem again we get BD upon DA is equal to BF upon FE. From these two equations we get BE upon EC is equal to BF upon FE. Let's see question 5 now. DF is parallel to OQ. DE is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. Since DE is parallel to OQ, we get PE upon EQ equal to PD upon DO. Since DF is parallel to OR, we get PD upon DO is equal to PF upon FR. From these two equations, we get PE upon EQ is equal to PF upon FR, which means EF is parallel to QR by converse of BPT theorem. Let's see question 6. A, B and C are points on OP, OQ and OR respectively such that AB is parallel to PQ and AC is parallel to PR. Show that BC is parallel to QR. In triangle POQ, PA upon AO would be equal to QB upon BO since AB is parallel to PQ. In triangle POR, PA upon AO would be equal to RC upon CO since AC is parallel to PR. From these two equations, we get QB upon BO is equal to RC upon CO. Therefore, BC is parallel to QR by converse of BPT. State which pairs of triangles in the figures given are similar. Now in triangle ABC and triangle PQR, angle A is equal to angle P both equal to 60 degree. Angle B is equal to angle Q both equal to 80 degree. And angle C is equal to angle R equal to 40 degree each. Therefore, by AA similarity criteria, triangle ABC is similar to triangle PQR. Part 2. In triangle ABC and triangle QRP, AB upon QR is equal to 1 by 2. BC upon RP is again 1 by 2. CA upon PQ is equal to 3 by 6, which is equal to 1 by 2. Therefore, triangle ABC is similar to triangle QRP by SSS similarity criteria. Let's see part 3. In triangle LMP and triangle DEF, MP upon DE is equal to 1 by 2. PL upon DF is again 1 by 2. However, LM upon EF is not equal to 1 by 2. Therefore, MP upon DE is equal to PL upon DF. However, both are not equal to LM upon EF. Therefore, triangle LMP is not similar to triangle DEF. Part 4. In triangle MNL and triangle QPR, it is given that MN upon QP is equal to 1 by 2. Angle M is equal to angle Q. Therefore, by SAS similarity criteria, triangle MNL is similar to triangle QPR. Part 5. In triangle ABC and triangle DEF, AB upon DF is equal to 1 by 2. BC upon EF is again 1 by 2. But we are not given that angle B is equal to angle F. Therefore, we cannot conclude that both these triangles are similar. Last part. In triangle DEF, the sum of all the angles is 180 degree. Or we can say 70 degree plus 80 degree plus angle F is equal to 180 degree. Therefore, angle F would be equal to 30 degrees. Similarly, in triangle PQR, sum of all the angles is equal to 180 degrees. Therefore, angle P would be equal to 180 minus 80 minus 30, that is 70 degrees. Now comparing both the triangles, we have angle D is equal to angle P, both equal to 70 degrees. Angle E is equal to angle Q, both equal to 80 degrees. And angle F is equal to angle R, each equal to 30 degrees. Therefore, by AA similarity criteria, we have triangle DEF is similar to triangle PQR. The given figure, triangle ODC is similar to triangle OBA. Angle BOC is 125 degrees and angle CDO is 70 degrees. We have to find angle DOC, DCO and OAB. So this is given and this is to be found out. As we can see, DOB is a straight line. Therefore, angle DOC plus angle COB is 180 degrees. That means angle DOC is 180 minus 125, that is 55 degrees. In triangle DOC, sum of the measures of the angles of a triangle is 180 degree. Therefore, angle DCO plus angle CDO and plus angle DOC is equal to 180 degrees, which gives us DCO plus 70 plus 55 is 180 degree. That means angle DCO is 55 degrees. Now, we are given that triangle ODC is similar to triangle OBA. Corresponding angles are equal in similar triangles. Therefore, angle OAB is equal to angle OCD, which gives us angle OAB to be equal to 55 degrees. So here are the three angles that we needed to find out. Angle DOC, angle DCO, angle OAB all equal to 50. Diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at the point O. Now, using a similarity criteria for two triangles, show that AO upon OC is equal to OB upon OD. In triangle DOC and triangle BOA, angle CDO is equal to angle ABO because alternate interior angles. Similarly, angle DCO is equal to angle BAO because these are also alternate interior angles where AB and CD are parallel to each other. Also, angle DOC is equal to angle BOA because these are vertically opposite angles. So, triangle DOC is similar to triangle BOA using the AAA similarity criteria. Thus, the corresponding sides are proportional. That means DO upon BO is equal to OC upon OA. Or we can say OA upon OC is equal to OB upon OD, exactly what we wanted to prove. In the given figure, QR upon QS is equal to QT upon PR and angle 1 is equal to angle 2. We need to show that triangle PQS is similar to triangle TQR. Now in triangle PQR, angle PQR is equal to angle PRQ. We are given that. Therefore, PQ is equal to PR because sides opposite to equal angles are equal in length. Also, we are given that QR upon QS is equal to QT upon PR and we just found out that PQ is equal to PR. Hence, we can say that QR upon QS is equal to QT upon QP. Now, in triangle PQS and triangle TQR, QR upon QS is equal to QT upon QP. Angle Q is common. Therefore, by SAS similarity criteria, triangle PQS is similar to triangle TQR. S and T are points on sides PR and QR of triangle PQR, such that angle P is equal to angle RTS. We have to show that triangle RPQ is similar to triangle RTS. Now in triangle RPQ and RTS, we are given that angle RTS is equal to angle QPS. Now angle R is equal to angle R because obviously they are common angles. Therefore triangle RPQ is similar to triangle RTS via AA similarity criteria. In the figure, if triangle ABE is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. We are given that triangle ABE is congruent to triangle ACD. Therefore, AB is equal to AC by CPCT and AD is equal to AE also by CPCT. Dividing equation 2 by equation 1, we get AD by AB is equal to AE upon AC. Angle A is common in both the triangles. Therefore, triangle ADE is similar to triangle ABC by SAS similarity criteria. Altitudes AD and CE of triangle ABC intersect each other at the point P. Show that triangle AEP is similar to triangle CDP and triangle ABD is similar to triangle CBE. Similarly, triangle AEP is similar to triangle ADB and triangle PDC is similar to triangle BEC. Let's start with part 1. In triangle AEP and triangle CDP, angle AEP is equal to angle CDP. Both are 90 degree. Angle APE is equal to angle CPD because they are vertically opposite angles. Hence, by AA similarity criteria, triangle AP is similar to triangle CDP. Easy, right? Let's see part 2 now. In triangle ABD and triangle CBE, angle ADB is equal to angle CEB because both are 90 degree. Angle ABD is equal to angle CBE because these are common angles. Hence, by AA similarity criteria again, triangle ABD is similar to triangle CBE. Next part is in triangle AEP and triangle ADB, angle AEP is equal to angle ADB. Both are 90 degree. Angle PAE is equal to angle DAB because these are common angles. Hence, by AA similarity criteria, triangle AEP is similar to triangle ADB. Moving on to the last one. In triangle PDC and triangle BEC, angle PDC is equal to angle BEC because both are 90 degree. Angle PCD is equal to angle BCE because these are common angles. Hence, again, by AA similarity criteria, triangle PDC is similar to triangle BEC. That's it. E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at F. Show that triangle ABE is similar to triangle CFB. Now in triangle ABE and triangle CFB, angle A is equal to angle C because these are opposite angles of a parallelogram. Angle AEB is equal to angle CBF because these are alternate interior angles as AE is parallel to BC. Therefore, triangle ABE is similar to triangle CFB via AA similarity criteria. Easy, right? ABC and AMP are two right triangles, right angled at B and M respectively. Prove that triangle ABC is similar to triangle AMP and CA upon PA is equal to BC upon MP. Now in triangle ABC and triangle AMP, we have angle CAB equal to angle MAP because these are common angles. Also, angle ABC is equal to angle AMP, both equal to 90 degree. Therefore, triangle ABC is similar to triangle AMP via AA similarity criteria. Easy, right? Let's go to the second part. Now, if two triangles are similar, then the corresponding sides are in proportion, right? Hence, CA upon PA is equal to BC upon MP. That's it. So, CD and GH are respectively the bisectors of angle ACB and angle EGF, such that D and H lie on sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC is similar to triangle FEG, show that CD upon GH is equal to AC upon FG. Also, triangle DCB is similar to triangle HGE. And then finally, triangle DCA is similar to triangle HGF. Now, we are given that triangle ABC is similar to triangle FEG. This means angle A is equal to angle F. Similarly, angle B is equal to angle E and angle C is equal to angle G because corresponding angles of two similar triangles are equal. Now, this obviously implies that half of angle C is equal to half of angle G. That means angle 2 is equal to angle 4. Also, angle 1 would be equal to angle 3. So, we have these 5 statements or equations that we would be using in our proofs. Let's start with the proof of part 1. In triangle ACD and triangle FGH, angle A is equal to angle F from 1. Angle ACD, which is angle 2, is equal to angle FGH, which is angle 4 by equation 4. Therefore, triangle ACD is similar to triangle FGH by AA similarity criteria. Well, this also implies that CD upon GH is equal to AC upon FG because corresponding sides of two similar triangles are always in similar proportion to each other. This proves our part 2. In triangle DCB and triangle HGE, angle DCB is equal to angle HGE from 5 and angle B is equal to angle E from equation 2. Therefore, triangle DCB is similar to triangle HGE via AA similarity criteria. Thus, we have proved part 2. Next, let's see the proof for the one remaining part, which is part 3. In triangle DCA and triangle HGF, angle ACD is equal to angle FGH from 1. Therefore, triangle DCA is similar to triangle HGF by AA similarity criteria. Thus, we have proved all the 3 parts now. In the given figure, E is a point on side CB produced of an isosceles triangle ABC with AB equal to AC. If AD is perpendicular to BC and EF is perpendicular to AC, prove that triangle ABD is similar to triangle ECF. Let's see the proof now. Angle ADB plus angle ADC is equal to 180 degree because these are linear pair. Angle ADB is equal to 90 degree. We are given that. Therefore, angle ADC is equal to 90 degree. Now in triangle ADB and ECF, we are given that ABC is an isosceles triangle where AB is equal to AC. Therefore, angle ABD is equal to angle ECF. Now angle ADB is equal to angle EFC, each equal to 90 degree. Therefore, triangle ABD is similar to triangle ECF using AA similarity criteria. That's it. Now tell me one thing. Why is it AA similarity criteria and not AAA similarity criteria? Comment below and let us. Sides AB and BC and median AD of a triangle ABC are respectively proportional to sides PQ and QR and median PM of triangle PQR. We need to show that triangle ABC is similar to triangle PQR. Given triangle ABC and triangle PQR, AB, BC, and median AD of triangle ABC are proportional to sides PQ, QR, and median PM of triangle PQR. That is, AB upon PQ is equal to BC upon QR is equal to AD upon PM, which implies that AB upon PQ is half of BC upon half of QR is equal to AD upon PM. Thus, AB upon PQ is equal to BD upon QM, which is also equal to AD upon PM, as AD is the median and hence BD is half of BC, and similarly QM is half of QR, which means triangle ABD is similar to triangle PQM by SSS similarity criteria, right? Now, these two triangles are similar. It also means angle ABD is equal to angle PQM because corresponding angles of two similar triangles are equal, which also means that angle ABC is equal to angle PQR. Now, in triangle ABC and triangle PQR, AB upon PQ is equal to BC upon QR. Also, we just proved that angle ABC is equal to angle PQR. Thus, triangle ABC is similar to triangle PQR by SAS similarity criteria. Easy. D is a point on the side BC of a triangle ABC such that angle ADC is equal to angle BAC. Show that CA square is equal to CB into CD. In triangle ADC and triangle BAC, angle ADC is equal to angle BAC. We are given that. Now angle ACD is equal to angle BCA because these are common angles. Therefore, triangle ADC is similar to triangle BAC via AA similarity criteria. We know that corresponding sides of similar triangles are in proportion, right? Therefore, base over hypotenuse of triangle ADC is equal to base over hypotenuse of triangle BAC. That means CA upon CB is equal to CD upon CA. This implies that CA square is equal to CB into CD. And this is what we wanted to prove. Sides AB and AC and median AD of a triangle ABC are respectively proportional to sides PQ and PR and median PM of another triangle PQR. We are to show that triangle ABC is similar to triangle PQR. We are given that AB upon PQ is equal to AC upon PR is also equal to AD upon PM, right? And we have to prove that triangle ABC is similar to triangle PQR. Let's do some construction first. Reduce AD to E such that AD is equal to DE. Join CE and similarly produce PM to N such that PM is equal to MN. Also join RN. Let's see the proof now. Now in triangle ABD and triangle CDE we have AD equal to DE by construction, BD equal to DC because AD is the median, it is given, and angle ADB is equal to angle CDE because these are vertically opposite angles. Therefore, triangle ABD is congruent to triangle CDE via SAS congruency. Now, this would imply that AB is equal to CE by CPCT, right? Also, in triangle PQM and triangle MNR, PM is equal to MN by construction, QM equal to MR since PM is the median, and angle PMQ equal to angle NMR because these are vertically opposite angles. Therefore, triangle PQM is congruent to triangle MNR. Therefore, PQ is equal to RN via CPCT. Now, we are given that AB upon PQ is equal to AC upon PR, which is also equal to AD upon PM, right? So, from equation 1 we have AB equal to CE, and from equation 2 we have PQ equal to RN. So, substituting AB with CE and PQ with RN, we get CE upon RN is equal to AC upon PR, which is also equal to AD upon PM. Now, would it be correct if I say that CE upon RN is equal to AC upon PR and is also equal to twice of AD upon twice of PM? Now, we can say that these are equal to AE upon PN because by construction AD is equal to DE and PM is equal to MN, right? Therefore, triangle ACE is similar to triangle PRN. SSS similarity criteria. Therefore, angle 2 is equal to angle 4. Similarly, angle 1 would be equal to angle 3. So, in this case, we would be joining BE and following the same steps, but we can also write that similarly angle 1 would be equal to angle 3. Therefore, angle 1 plus angle 2 would be equal to angle 3 plus angle 4, or we can say angle A is equal to angle P, right? Now, in triangle ABC and triangle PQR, we have AB upon PQ equal to AC upon PR. We are given that. Now, from equation 3, angle A is equal to angle P. Therefore, triangle ABC is similar to triangle PQR via SAS similarity criteria. Hence proved. A vertical pole of length 6 meter casts a shadow 4 meter long on the ground, and at the same time a tower casts a shadow 28 meters long. Find the height of the tower. We are given that length of the vertical pole is 6 meters, shadow of the pole is 4 meters. Let's assume that the height of the tower is h meters, and we are given that length of the shadow is 28 meters. Now in triangle ABC and triangle DEF, angle C is equal to angle F because angular elevation of the sun is the same. Angle B is equal to angle E, both equal to 90 degree. Therefore, triangle ABC is similar to triangle DEF via AA similarity criteria. Therefore, AB upon DE is equal to BC upon EF because if two triangles are similar, corresponding sides are proportional. That means 6 upon H is equal to 4 upon 28, or H is equal to 6 into 28 upon 4, that is H is equal to 42 meters. Hence, the height of the tower is 42 meters. Well, there is one more way to solve this question. If AD and PM are medians of triangles ABC and PQR respectively, where triangle ABC is similar to triangle PQR, prove that AB upon PQ is equal to AD upon PM. Let's see the solution now. We are given that triangle ABC is similar to triangle PQR, which implies that AB upon PQ is equal to AC upon PR is also equal to BC upon QR. Why? Well, because the corresponding sides of similar triangles are proportional to each other, right? Now, angle A would be equal to angle P, angle B would be equal to angle Q, and angle C would be equal to angle R because corresponding angles in two similar triangles are equal. Now, BD is half of BC because AD is the median. which obviously means BC is twice of BD. Similarly, QM is half of QR, which again means that QR is twice of QM. Now, from these four equations, we have substituting 3 and 4 in 1, we get AB upon PQ is equal to twice of BD upon twice of QM. Or we can say that AB upon PQ is equal to BD upon QM. Now in triangle ABD and triangle PQM, from equation 3 we have angle B equal to angle Q, and also from equation 5 we have AB upon PQ equal to BD upon QM. Therefore, triangle ABD is similar to triangle PQM via SA's similarity criteria. Now, this would imply that AB upon PQ is equal to BD upon QM and is also equal to AD upon PM. And this is what we wanted to prove, right? So, hence proved. Hope you've understood the chapter thoroughly now. If we have made it any simpler and more interesting for you, don't forget to give us your love by liking the video and subscribing to the channel. And yes, remember to keep shining bright because you are a star. Bye bye. Have a good one. Hope you've understood the chapter thoroughly now. If we have made it any simpler and more interesting for you, don't forget to give us your love by liking the video and subscribing to the channel. And yes, remember to keep shining bright because you are a star. Bye bye. Have a good one.